Before you jump right into data-driven security analytics, it is important to ensure you at least have a basic familiarity with the two most prominent languages featured in nearly all of the data analysis scenarios, Python and R. Although there are abundance of tools available for data analysis, we feel these two provide virtually all the features necessary to help you to go from data to discovery with the least amount of impedance. For people with an existing programming background, getting up to speed with Python should be pretty straightforward, and you can expect to be fairly proficient within 3 to 6 months. Your code may not be Pythonic, that is, utilizing the features, capabilities, and the syntax of the language in the most effective way, but you will be able to get a lot of useful stuff done. Python's flexibility and extensibility were especially appealing to the scientific, academic, and industrial communities, and which also resulted in a very broad and quick adoption in these fields since 2000s. For those who are new to statistical language, becoming proficient in R may pose very of a challenge. Statisticians created R. If you can commit to suffering through R syntax and package nuances, you should be able to make some good progress in 3 to 6 months as well. R makes it remarkably simple to run extensive statistical analysis on your data, and then generate informative and appealing visualizations with just a few lines of code. Both Python and R provide an interactive execution shell, or IDE environment, that has enough basic functionalities for general needs. Why we need both? There are times when the flexibility of a general-purpose programming language comes in very handy, which is when you use Python. There are other times when 3 lines of R code will do something that may take 30 or more lines of Python code to accomplish. Since your ultimate goal is to provide insightful and accurate analysis as quickly and as visually appealing as possible, knowing which tool to use for which job is a critical insight you must develop to be as effective and efficient as possible. By having both tools in your toolbox, you should be able to tackle most, if not all, of the tasks that come your way. If you do find yourself in a situation where you need functionality you don't have, both R and Python have vibrant communities that are eager to provide assistance and even help in development of new functions or modules to feed emerging needs. Before going off and playing with data, we need to develop a solid research question first. In this section, we'll work on an example problem given to you by the manager of the Security Operations Center, SOC. It seems the SOC analysts are becoming inundated with the trivial alerts, even since a new data set of indicators was introduced into the SEIM, Security Event and Information Systems. They have asked for your help in reducing the number of trivial alerts without sacrificing visibility. This is a good problem to tackle through data analysis, and we should be able to form a solid, practical questions to ask after we perform some exploratory data analysis and hopefully arrive at an answer. Let's use one security data analytics example on Alien Vault's IP reputation database. This is a freely available data set that contains information on various types of badness across the internet that include IP addresses. First of all, understanding the data set by applying your security domain knowledge. For each field description, see the link here. In this data set, there are data fields such as reliability, risk, and X. These are integers. They are the index score. Other data fields such as IP address, type, country, locale, and coordinates are character strings. The IP address is stored in the dotted quad notation, not in host names or decimal format. Each record is associated with a unique IP address, so there are about 258,000 IP addresses. Each IP address has been geolocated into the latitude and the longitude pair in the chords fields, but they are in a single field separated by a comma. You will have to parse and ETL these fields further for analysis. Now that you have a general idea what the variables and the data set they look like, it is time to bring your security domain expertise into the mix to explore and discover what is interesting about the data. A good first exploratory step is to look at the basic descriptive statistic or 5-number summary of a data set on the variables, minimum and maximum values. And taking the difference of this will give you the range. Median, the value at the middle of the data set. First and third quartiles, the 25th and the 75th percentile. Or you could think of it as the median value of the first and the last half of the data, respectively. Mean, sum of all values divided by the number of accounts. As you look at these results, note that the reliability column spreads across the documented potential range of 1 to 10. But the risk column, which Alien Vault says has a documented potential range from 1 to 10, only has a spread of 1 to 7. You can also see that both reliability and the risk appear to center on the value of 2. Both Python and R languages have built-in functions to calculate these descriptive statistics, such as a summary in R and describe method in Python. The data distribution graph has the potential to provide a whole new perspective, oftentimes giving insights that numbers alone cannot reveal. We start with a simple bar chart to get a very quick visual overview of the country, risk, and reliability factors. First, it is the distribution summary by country. It shows that China and the US together account for almost 50% of the malicious nodes in the list. Second, it is distribution summary by risk. Look at the risk distribution graph. You can see that the level of risk of the most of the nodes is negligible, which is so low that they can be disregarded. There are other elements that stand out with this data though, foremost being that practically no endpoints are in categories 1, 5, 6, or 7 risk score, and none in the rest of the defined possible range from 8 to 10. This might be a sign to you that it's worth digging a bit deeper. But anomaly is significant evidence of bias in the data set as well. Thirdly, it is a distribution summary by reliability. From its distribution graph, the reliability rating of the nodes appears to be a bit skewed, that its distribution extended to one side of the mean or central tendency. The values are mostly clustered in values of 2 or 4, with not many ratings above level 4. The fact that it completely skips a reliability rating of 3 should raise some questions in your mind. It could indicate a system flaw in assignment of the rating. Or it could be that you can at least have 2 distinct data sets. Either way, that large quantity of 2 and 4s and the low quantity of threes might be a sign that you should investigate further. Consider both the problem and the primary use case for the alien vault reputation data. Imposing it into a SIEM, or intrusion detection system, or intrusion prevention system, to alert incident response team members, or to log, block malicious activity. How can this quick overview of reputation data influence the configuration of the SIEM in this setting to ensure that least number of trivial alerts are generated? So the practical question is, which nodes from the reputation database represent a potentially real threats? Some form of a triage and prioritization must occur. And it is far better approach to base the triage and prioritizations on statistical analysis on data and evidence on the data rather than a gut feeling or solely on expert opinion. It is possible to see which nodes should get your attention by comparing the risk and the reliability factors. To do this, you're using contingency table, which is a tabular view of the multivariate frequency distribution of specific variables. In other words, a contingency table helps show relationship between two variables. After building a contingency table, you can take both a numerical and a graphical look at the results to see where alien vault nodes clustered. It is very apparent that values in this data set are concentrated around 2, 2, where risk is 2, reliability is 2. Now turn your attention to the type variables, such as a malicious host, malware domain, malware IP, etc., to see if you can establish a relationship with risk and the reliability ratings in specific type. In the figure, you can see the malware domain type has risk rating limited to 2 and 3s, and the reliability is focused around 2. You can also start to see the patterns in the other categories as well. Now, you can remove malware domain type from the next iteration of analysis due to its low risk scores. Also, it looks like malware distribution does not seem to be contributing any risk. So you can filter that factor out of the remaining types as well. After filtering out 2 types, malicious domain and malicious distribution, you've reduced the list to less than 6% of the original and have honed in fairly well on the nodes representing the ones you really should care about. If you want to further reduce the scope, you could filter by various combinations of reliability and/or risk. This rather simple exploratory analysis through parsing and slicing down here doesn't show which variables are most important. It simply helps you understand the relationships and the frequencies they occur.